Algebra 2, Chapter 9.1, Exercises 11 through 20. These exercises continue our exploration of inverse variation. And in this case, we're going to compare direct variation to inverse variation in these exercises. And an inverse variation would be one where, well, we're just going to examine this here. If you look at the prior video, there are going to be some examples, but here we have one. If a guitar string 65 centimeters long vibrates with a frequency of 110 hertz, at what frequency would the guitar string vibrate when the guitar reduces the guitar string length to 22 centimeters? So we're told that these two variables, they vary inversely. So the frequency f varies inversely with the length. And there's going to be here on the right side, the numerator, a constant of variation. I'll just constant of variation. So what that ends up being here in this instance, if we have a guitar string 65 centimeters in length, so we'll put A over 65 with frequency of 110 hertz, our constant variation is going to be 65 times 110. So A equals 65 times 110. And what we have, I'm going to just take a few liberties here. That could be a pretty large number. So 65 times 110, just to avoid using calculators, could be 65 times 100 plus 65 times 10, which is going to be 6,500 plus 650. And that's going to be 7,150. So that's going to be our constant variation that we're going to work with. And here we're asked the question, at what frequency would the guitar string vibrate when the guitarist reduces the string's length to 22 centimeters? So here we have frequency is equal to what we found out as 7,150 for a constant of variation over our string length. And now we're going to try a string length of 22 centimeters and see what that gives us. And if we just divide that out, I'm going to do some long division here. 22, 7,150. How many times is 22 going to 7? None. How many times is 22 going to 71? Well, that's going to be 3 times. 3 times 22 is 66. 71 minus 66 is 5. And we bring down this 5. How many times does 22 go into 55? Twice. 2 times 22, 44. 55 minus 44, 11. Bring down the 0. How many times does 22 go on to 110? 5. So our answer is going to be, our frequency is going to be 325 hertz. I'll put Hz. Not a super high number. I think A is A above metal, C is 440 hertz. I don't know exactly what it is. But let's go into our next problem. And this next set of problems, we're going to look at a bunch of tables. And as the instruction says, determine whether two variables vary inversely or directly. Now, we've talked about an inverse variation. But a direct variation is going to be of this type, where we have y equals m, or m for a slope x. So this would be an example of a direct variation. I'll just write down direct. Whereas for inverse variation, we're going to have y is equal to a constant variation over x. So inverse. Now you notice we don't have in a direct variation, we don't have any y-intercept other than 0. We're going to go right through the origin, the point 0, 0 with a direct variation. Well, in this case, what you're looking for is x is increasing while y is decreasing. So they are going, here we're going up for y, but down for x. And these arrows are in different directions, so direct variation is not a possibility here. So I'm going to put the form here, y equals a over x. And then working to the right here, we will try any one of these points. We'll try, I guess we'll try this 3, 10. 10, which is y, is equal to our a, which is our unknown constant variation, over our x value, 3. And if we cross multiply, a is going to be equal to 10 times 3, or 30. So now we have our equation, which is going to be y equals 30, our constant variation, over x. I hope you can see that if we take 30 divided by x, if we take input of x, 30 divided by 1 is 30. If we take 10, 30 divided by 10 is 3. If we put in 4 for x, 4, 30 divided by 4 is 7.5, so that checks out. So now we're asked the question, what is y when x is 15? So we'll say y is equal to 30 over x is 15, which equals 2. So we'll say y is equal to 2. And then we see that 2 times 15 equals 30, just as 7.5 times 4 equals 30, just as 3 times 10 equals 30, just as 30 times 1 equals 30. Next, I just want to go ahead and take a quick look at 14. We can see in example 14 that y value is going up while x value is also going up, right? So 14 would not be an example of an inverse variation, possibly a direct variation. Let's go on to 15 here. The table gives the cost in dollars per person when friends share in renting a mountain cabin for a weekend. I think in my class, I've talked about the situation where my friend Craig invited people to come over for a pay-per-view fight, and each of us, as viewers, donated a proportionate share, and that the average cost per person depended upon the number of people paying into the deal. So more friends to share the costs lowered the average cost per person. It's the same sort of deal right here. So the general format is we have an inverse variation. We're asked what is the cost per person, which is C. So C is going to be equal to some constant variation over the number of people. So to find out what that constant variation is, which we're going to need to do to solve for 6 friends in place, we're going to need to have, we can use any of these points. I'm going to take the first one here, 2 and 90. So our cost per person, which is 90, is going to be equal to our constant variation A over the number of people 2. And if we cross multiply, A is going to be equal to 2 times 90, or 180. So our average cost per person is going to be A over, and A is, we figure that out to be 180, our constant variation, over P. And so now we are asked the question, if we have 6 friends sharing the cabin, we're going to have our average cost per person going to be C equals 180 divided by 6. And that would be, our average cost per person is going to be $30. And let me make, it's $30. Yeah, that's more unambiguous. So equals $30. It really makes sense. And you notice in the table, all the input and output values together, multiplied together, will equal our constant variation, 180. Next on our problem, 17. The table gives the cost in dollars running a rowboat at a lake for various amounts of time. In hours, what is the cost of running a rowboat for 3.5 hours? Well, here we have a situation where our time T is going up at the same time our rental cost C is going up. So this would not be a candidate for inverse variation, but rather direct variation. So I'm going to write the format here, y equals m, which is our slope, x. And in this case, our variables are different. We want to have time, so we'll say t is going to be equal to our constant of direct variation, m, or slope, times the rental cost, c. Okay, so what we're going to have is our t in this case we'll use 2 is equal to m well, we want to go ahead and work that differently, don't we? We want to work that out as, I want to go ahead and put that down differently. we're going to put that down. It's what is the cost of running a rowboat. So we're going to say cost is going to be equal to m times t is how we're going to do this one. So in this instance, if we take the first point here, we have 28 is going to be equal to m times 2. And so to find out what m is, if we divide both sides of this equation by 2, we get m is equal to 28 divided by 2, or 14. And so that's the constant we're looking for. So we say, we can check out if this is correct. 2.5 times 14 should equal 28. Or actually, yeah, that should be right. So we go ahead and multiply. We get 4 times 5 is 20. 4 times 2 is 100. And 1 and 2 like this. And we bring this out, we get 3, 5, 0. Move the decimal place over 1. Check. And if we multiply 3 times 14, we also get 42. So running a boat for 3.5 hours, I'm going to do that. Your cost is going to be equal to 14, which is m, times 3.5 hours. So 14 times 3.5. Actually, we could just take this 2.5, we could just add to it 14. So you should get 49. So anyway, 4 times, that's going to be 20. 4 times 3 is 12 plus 4, 1, 4. And then we put 3, 5 here. So we get 490. So yes, 49. So the cost for running a rowboat for 3.5 hours is going to be $49. And there we have it. That is our answer for number 17. Okay, the last one I'm going to do in this exercise set is 19. The table gives the speed of a bicycle in miles per hour. And it says what is going to be bicycle speed when the cyclist pedals at a rate of 72 revolutions per minute. So pedaling rate is going to be rate in revolutions per minute and bicycle speed. Well, if you don't have a difference in gear at all, it just makes sense. There's going to be a direct proportionality. And you can see that as the rate on top goes up, bicycle speed is going up. So we want to know the bicycle speed. So bicycle speed is going to be equal to m times the rate. In this case, our speed is going to be any one of these values here. I'll pick this 60 and 10. Our speed 10 is going to be equal to our m times our rate, which is 60. So to find out what m is, if we divide both sides of the equation by 60, we get m is equal to the fraction 1/6. So that's going to be our slope, our rate of change. And if you can see, if we divide 30 by 6 or multiply 30 by 1/6, we get 5. Of course, 1/6 of 60 is 10, and 1/6 of 90 is is 15. So I'm going to put the general equation here. S equals 1/6 of R. And now going ahead and applying that to our speed at 72 revolutions per minute. If we have 1/6 of 72, well, 72 divided by 6 is 12. So S is equal to 12, and that's the units miles per hour. So 12 miles per hour. And then just to look here at number 20, just to see that it's here. It looks like for number 20, that looks like an inverse variation. I hope you've been able to see in these exercises some comparing and contrasting of inverse variation as opposed to direct variation, and just basics to look for in those. Good luck, and thanks for viewing.